చూడండి. Okay, okay, thank you. Okay, okay, thank you. మీరు ఇక్కడ ఉందంటే మీరు మీకు స్క్రీన్ షేర్ అవుతుందా? స్క్రీన్ షేర్ అవుతుంది. Okay, now let us start now. Yesterday class, we have to complete some other equivalence forms, and according to that, we have to construct the truth tables. Okay, that's all. Now, yes, just you have to observe clearly. What is the normal form? Here already I have to establish yesterday some of the equivalence or formula for solutions and some other relations also there. Now here what is the concept of sum of product and the product of sum? Okay. Now that is the disjunctive normal form. Just very good. What is the disjunctive normal form? What is the conjunctive normal form? Okay. Now, before that, we have to explain the disjunctive normal form and the conjunctive normal form. You can observe clearly here. Let capital A is one of A be the one of the statement here. That statement we are taking the some of the expressions that is atomic variables. Now that atomic variables is located as given this in the statement. Okay, P1, P2, and so on, Pn. Okay, now that's it. Now this statement you have to express the sum of the atomic variables and consider all possible assignments of truth values and obtain the resulting truth values of the formula. Then we get a truth value for A. Already yesterday I have to I told this expression is also here. This truth table containing now what about the expression here? 2 power n rows may show. Now, because here consisting n atomic variables, and we get observe here, that is the consider 2 power n truth table containing rows they show. Now, first point is the truth value T for all possible assignments of truth values to the n variables. Okay, that is the identically or tautological expression here. Now, we have the second point. Okay, the truth value capital F for all possible assignments of truth values to the n variables. A is said to be a contradiction or identically false here. Okay, very good. Next one, third one, the truth value capital T for at least one combination of truth value assigned to P1, P2, and so on, Pn. Now, in case capital A is said to be a satisfiable part. Okay. Now, this problem of determining a finite number of steps, whether a given statement formulate tautological or contradiction or at least satisfiable, is known as a decision problem. Now this concept is very important. Now we have to consider this type of consideration. Now what is that? These three conditions we have to apply for the observing of the problem and the determining the problem a finite number of steps. Okay, we are taking finite number of steps. That is the atomic variable. To the atomic variables for the consideration of given the statement. Okay. Whether a given statement formula is a tautology, either tautology or contradiction, or at least satisfiable. Just you have what is the decision problem in examination is given either short notes or short answer or filling the blanks, whatever it is. Decision problem means the problem of determining in a finite number of steps whether a given statement formula is a tautology or contradiction or at least satisfiable is known as decision problem. Okay, that's it. Hello. Voice clarity, are you hearing me? Are you here? Voice
Yes, sir.
clearly?
Yes, sir.
Hello?
Yes, sir.
Hello?
Hello.
Hello? No. Hello? Hassan? Voice clear or not? Please raise your hand or any other. Okay? Very good. One of the person was here. Raise the hand. Okay, voice clarity visible out. Yeah, thank you. Thank you. This person is also Galaxy of okay. Are you clear?
Yes, sir.
Person no, somebody is here. Okay. Galaxy A32. No. Near on the person. Okay. Anybody is here. Now, according to this one, given the statement formula a tautology or a contradiction or at least satisfiable, that is called a decision problem. Okay, that's enough. What is the reduction to normal form? Now, from the discussion made above, it is evident that every decision problem in statement, yes, please stay on the line. Okay. Now, here is also clearly that's it. Now, the problem of determining a finite number of steps whether a given statement formula is a tautology or a contradiction or at least satisfiable is known as a decision problem. And according to this one, this type of construction logic has every decision problem. So, express the some examination is given, define decision problem and explain the characters. Means every decision problem in a statement logic has a solution. Decision problem of the statement, everybody is there, he has a logic solution there. Since it involves construction of truth table, a certain number of steps. What are the please explain that step means? However, the construction of truth table for formula involving large number of variables. Large number of variables means here n is greater than or equals to 6, and evaluating them is quite tedious. To solve such a problem, we consider alternative procedure known as reduction to normal form. Okay, what is the reduction normal form? Reduction to normal form explained from every decision problem in a statement logic has a solution. It involves construction of the truth table. Now, the reduction to normal form is Chapali ante. First of all, single decision problem which define chestunam, and according to that involves construction of a truth table, a certain number of steps. Okay, that's enough. Now, according to that construction of truth table involving large number of variable, large number of variable means here n is greater than or equals to 6. That's enough. And evaluating them is a quite tedious. Okay. Now, to solve such problems, we consider alternative problems. Consider alternative procedures. Yes, very good. Consider alternative procedure known as reduction to normal form. That's enough. Now, here, just you have to see this one. What is the before defining normal form? We shall define the elementary product and the elementary sum. Normal form will explain children in the elementary product and elementary sum and clarity. Okay, what is the elementary sum and elementary product? Now, these definitions are also very important concept for upcoming examinations. Now, that is the final examination. Now, what is the elementary product or elementary sum? The conjunction of atomic variables. Atomic variables notated as here. Suppose capital A is one of the proposition is there. Okay. Now that proposition. Okay. According to the proposition, atomic variables already just seen this one. Now these are all atomic variables for concerned in the statement. Now, according to this one, conjunction of atomic variables and their negations. Okay, conjunction of atomic variables and their negation. Now here the conjunction represented as a product of atomic variables and their negations. In a statement of the formula is called elementary product. Okay, so here clearly is clear definition. Elementary product is the conjunction means and the representation. And means okay, please stay on the line just a minute. Okay, and here, according to this one, the conjunction of atomic variables and their negation in a statement, the formula is called elementary product. Suppose here P1, P2 is a P1, P2, P3. Here n is greater than or equal to 6 here. Okay, just a minute. Yes. Now, here the according to the elementary product, then you have to define the product of in two variables. That is the representation in between these atomic variables. Suppose here one of the example of elementary product. Suppose P and Q atomic variables, then capital P is one of the statement. Okay, and according to that P and the negation of P, that is also elementary product. Negation P and the Q, that is also atomic product. Elementary product. P and the negation Q, that is also elementary product. And the negation P and the Q and the negation Q. So in between conjunction, you have to represent it with the negation of the statements in between the consequent statement. That statement is also sometimes okay, negation P and the Q. That is the representation of the part. Negation P and the Q and the negation Q. This is also elementary product. Okay, that's enough. Now, this is the elementary product in two variables. Okay, in between how to express the elementary product, how to represent the elementary product for the given statements. Okay, that's enough. Now here, definition of elementary sum. What is the elementary sum is here? The disjunction, the above definition, elementary product represented as the conjunction connectivity. And here, disjunction means that is the summation of the atomic variables and their negation of a statement formula. This definition is also very important. What is the elementary sum? Elementary sum means the disjunction means disjunction sum of atomic variables and their negations of a statement formula. That is also called elementary sum. Okay. So elementary sum is completely depends upon the disjunction of this part. And now that represented as one of the example is P and Q are some atomic variables. That is P negation P or Q, P or negation P, P or negation Q. These examples are represented as elementary sum of two variables. Okay, that is the clear part. Okay, there is no doubt. Now, define the elementary sum and elementary product with examples. That type of question is also given here. Okay, that's it. Next one. So, here, according to this one, what is the factor of an elementary sum or product? What is the factor of elementary sum or product? Means any part of elementary sum or product which is also a elementary sum. Product is called a factor of the elementary sum or product. So elementary sum, either the elementary sum or product, whatever it is there, that is also one of the any you are taking in any part. the part which is also an elementary sum. Elementary sum తీసుకుంటే దాని elementary part, elementary sum or product తీసుకున్నట్లయితే అది elementary sum అయినా అవ్వచ్చు, product అయినా అవ్వచ్చు. That type of factor is called elementary sum or product is there. There is no. Now here what is the example of the factor of an elementary sum or product? This type of examples will also clearly. What is the factor of this one? Suppose negation P or Q. Here one of the factor. Negation P or Q is a factor. Now, what is the elementary product? Negation P or Q. If negation P or Q is a factor, then the elementary product is negation P or Q and negation Q. Okay. So first two statements. Okay. Now consideration that is also here. Negation P or Q and negation Q. This is also a P or negation P or Q of the factor. That's enough. Now here disjunctive normal form. Now the concept is disjunctive normal form. What is the disjunctive normal form? Short notated as a DNF. Clearly is here. Okay. Explain the negation P or Q factor means that elementary product is negation P or Q and the negation Q. This is the factor of negation P or Q. Okay. So this elementary product of the factor is negation P or Q. Now at the same time, disjunctive normal form. What is the disjunctive? Now normal form is also represented with respect to the connectivity is disjunctive part. That is also called a disjunctive normal form. Now that formula, which is an equivalent to the given statement formula, consisting of a sum of elementary products. Already in the disjunction, we have to explain the sum of the product. Sum of the product. That is the elementary sum is also explained here through the disjunction part. Now a formula which is an equal to the given statement formula and consisting of a sum. Sum means here disjunction of the elementary product is called disjunctive normal form. Whereas the sum of product of the form of the given formula. Disjunctive normal form in sometimes that is also called sum of product of form of the given formula. That's okay. That's enough. We shall now establish a result with respect to the elementary products which is frequently used in deriving the disjunctive normal form. Now, first of all, we must know what is the definition of disjunctive normal form. Now, at the same time, this is also called the sum of the product of form of the given expression. Now, the definition is also very important. First of all, we have to know the concept of what is the sum. Sum is also in the same manner distinction of this part. That is the B type, B connectivity. Now B connectivity in the set of the symbol is union representation. Union means that is for all the summation of this part. Okay, that's it. Okay. Now everybody presenting here. Do you understand? Please respond. Okay. Please respond. Everybody is here. This person. Okay. Respond. Never say something. Okay. That's it. Answer. Are you clear? Okay. Thank you. Thank you. Next one. To observe given this theorem, what is the necessary and sufficient condition for an elementary product to be identically false? Define DNF and prove that the necessary and sufficient condition for an elementary product to be identically false is that at the same time this is also called the statement again repeated as which contain at least one pair of factor in which one is the negation of the other. At least a pair of factors కలిగి ఉంటూ negation of the next దానికి negation అవుతుంది అని చెప్పమన్నారు. సో డిస్జంక్టివ్ కాన్సెప్ట్ చెప్పేటప్పుడు కానివ్వండి, కంజంక్టివ్ కాన్సెప్ట్ చెప్పేటప్పుడు కానివ్వండి, అదంతా కూడా మన నెగేషన్ మీద మనం చూపించడం జరుగుతుంది. నెక్స్ట్ వన్ హియర్ అట్ ద సేమ్ టైం
హలో
చెప్పండి చెప్పండి
సార్. మీ వాయిస్ కొంచెం లో అంటే స్లో అంటే చిన్నగా వస్తుంది, కొంచెం క్లియర్ గా క్లారిటీ లేదు సార్.
క్లారిటీ లేదమ్మా, నేను ఈరోజు సిస్టమ్ తీసుకున్నాను. ఓకే ఇప్పుడు చూడండి కనిపిస్తుందా క్లారిటీ? ఓకే మేడం గారు క్లారిటీగా ఉందా?
లేదు సార్, చాలా చిన్నగా వినిపిస్తుంది మీ వాయిస్. Hello.
వినపడుతుందమ్మా? హలో
Hello.
అమ్మా, నాకు మీ వాయిస్ వినపడుతుంది. ఇప్పుడు వినపడుతుంది మీకు?
Okay, okay, sir.
ఓకే, థ్యాంక్ యూ. Okay. Next one, you have to observe this one, this theorem. A necessary and a sufficient condition for an elementary product to be identically false. Now, this theorem is also completely depends upon the disjunctive normal form. Now, according to the disjunctive normal form, here necessary and sufficient condition of the part elementary product to be identically false. Yes, right. Is that at the same time the statement it contains at least one pair of factors in which one is the negation of the other. That is the theorem. Okay, that is the statement is also. Now here the clearly proposition. Proposition means a statement. Okay, that's enough. Okay. Now here the proof is that what is the recall of the part? Any statement variable. Suppose A being one of the proposition is here. So there is also statement where the variable is there. We have shown that A and negation A. మనం ఇక్కడ డిస్జంక్షన్ కాన్సెప్ట్ చెప్తున్నాం కాబట్టి కాన్సెప్ట్ ఎలా చూస్తున్నానండి? ఇక్కడ నేను కాంట్రడిక్షన్ కాన్సెప్ట్ చూస్తున్నానండి. చూడండి, డిస్జంక్షన్ అంటే ఇక్కడ మనకి ఆర్ అని చెప్పాలి. సో ఈ ఆర్ రిప్రజెంటేషన్ చెప్పడానికి నేను ఇక్కడ కాంట్రడిక్షన్ పార్ట్ ఏ అండ్ దేంతో చెప్పాలండి? Now with respect to we must A and the negation of the A. Now that is the consideration of the contradiction part. Following that, if you come across a factor A and the negation A is an elementary product. Okay. Now one of the factor is A and the negation is suppose you have the assumption of this here. Here the assumption of the part is A and the negation of A is an elementary product. Then such product is identically false. That is the recall of this part. Now that statement is also necessary part is also proved here. Okay. Suppose A and negation A contradiction like saying automatically మనకి కాంట్రడిక్షన్ చెప్పాను కాబట్టి దాన్ని దేన్ని యూస్ చేయొచ్చండి. Now that factor must be expressed into the elementary product. Such type of product is elementary product ఎప్పుడైతే చెప్పామో elementary sum elementary product గా తీసుకుని చెప్పాము ఆ product ఏమవుతుంది? ఐడెంటికల్లీ ఫాల్స్ అవుతుంది. సో ఆటోమేటికల్లీ A or negation A and the negation A is also contradiction is also true అని చెప్తున్నాము. So this is the identically false. Next one, conversely, the converse part the first elementary product is identically false. Okay, first of all, you have to take an elementary product is identically false and it does not contain. Okay, here the part at least one pair of factor, but here in the converse of the part it does not contain at least one factor in which one is the negation of the other. Okay. So now assign a truth value capital T to all the variables true values. That is the negated variables contained in the product. Following the assignment, you consider the elementary product as the truth value, which is a contradiction. So we are taking the assumption is there does not contain at least one factor. Here the truth value is also consideration. That is the contradiction. Assumption is for assumption contradiction by the truth value P and చెప్పాను. False అని తీసుకున్నాము, ఇక Q అని చేయడం జరిగింది. In this manner, to obtain a disjunctive, and the result is also false. That's enough. This is the end of the part. Here, the above theorem is also here. There is the end of the part. But here, what are the characteristics of disjunctive normal form? Means explain briefly disjunctive normal form. Within the statement or proposition. Statement means that is the proposition of disjunctive normal form for a given statement formula. The following procedure is adopted. Okay, that's it. So in the given formula contain a conditional and or a biconditional part. Just you have to observe what is the concept of disjunctive normal form. Okay. Now then there are expressions. These 3 points you have to observe. These 3 points very important. Explanation key. These 3 points will be mentioned here. First thing is and or biconditional part implication we replace the factor containing these connectivities by an equivalent formula. ఈ యొక్క పార్ట్ని కనెక్టివిటీస్ ని ఈక్వివలెంట్ ఫార్ములా తోటి కన్సిడర్ చేయాలి. సో దట్ ద రిజల్టెంట్ ఫార్మ్ ఇస్ ద ఫ్రీ ఫ్రమ్ దీస్ టు కనెక్టివిటీస్. అండి ఈ రిజల్టెంట్ ఫార్మ్ ఏమవుతుందండి, ఈ టూ కనెక్టివిటీస్ ని కూడా నుంచి కూడా ఫ్రీగా మనం చెప్పచ్చు. Second point, if negation is applied, already the above example is also there. Okay, see this one. A be the statement and the connectivity is the and. Okay, negation is also considered. Okay, this is the second point. If negation is applied to a part of the given formula or to the formula itself, okay, we must use the De Morgan's law. ఇక్కడ మనం ఎప్పుడైతే నెగేషన్ ఫార్ములాని అప్లై చేసామో డి మోర్గన్ లా కాన్సెప్ట్ ని కూడా కన్వర్ట్ చేసుకున్నట్లయితే నౌ ఇట్ ఈస్ కన్వర్టింగ్ టు ద సేమ్ అండ్ ఈక్వివలెంట్ ఫార్ములా అండ్ అట్ ద సేమ్ టైం నెగేషన్ ఇస్ అప్లైడ్ ఓన్లీ టు ద వేరియబుల్స్. నెగేషన్ దేంట్లో ఓన్లీ వేరియబుల్స్ మాత్రమే నెగేషన్ అప్లై చేయాలి. ఓకే, దట్స్ ఇట్. Now the important another third point of DNF is disjunctive normal formula. If you some part of parts of the resultant form the obtained still contain one or more product of sums. Suppose one or more product of sums like apply distributive law repeatedly. Now again you have to apply the distributive conditions there. Then they are required disjunctive normal results. Okay, that's another. These are important conditions of this part. First condition, second and third points. These 3 points must be represented as the explanation, especially explanation of disjunctive normal form. There is no doubt. Thank you. Okay, next one. See this example here. Obtain disjunctive normal form of P and P to Q. P and of P to Q. Now, just to have to observe the question paper or model paper at the end of your PDF material or end of the textbook is there. Now there are so many asking the questions is really disjunctive normal form and conjunctive normal form. Okay, now this is the short answer. Obtain the disjunctive normal form P and of P to Q. P and of P to Q. Okay, this is. Now the solution is P and of P to Q if and only P and of negation P or Q. P and of this expression in the equivalence of P and P to Q negation P or Q right. The representation is negation P or Q right. Now this is the first point. Second point is the negation P is also applied here. Now third point, the disjunctive form is there. P and the negation P are end of R. P and the negation P are P and Q. Okay, P and the negation P are P and Q. Okay, now both are transferred. One is the another one. That is the third point. P and the negation P are P and Q. Okay, this is the final expression of through the distributive condition. That's enough. This is the simple answers for the short answer questions. Okay, next one is here. Just please stay on the line. Now look at this example is also here. What is this? Obtain the disjunctive normal form of negation of P or Q. Okay, this is the proposition. Okay, negation of P or Q if and only if P and Q. Okay, this is the concept. Now negation of P or Q is an equivalent P and Q. Okay, so in between the connectivities is or and. That is the given. In between equivalence concept is here. Now if and only if negation of given the part is also considered in the given the row. Negation of P or Q and P and Q are this one. Negation of P or Q and P and Q are negation of P or Q and negation of P and Q. Because just to see this according to this expression. What is the this is P? Entire the part is first part. This is the second part. Okay. Now through this expression, P is an equivalent to Q if and only if P to Q and Q to P. Okay, P to Q and Q to P. Now this expression is considered giving this expression. Okay, this part is A, this part is B. Now the formula is also applied in between this here. Now negation P R Q and negation Q R P. At the same time, this expression represented as P and Q. Negation P R Q represented as P and Q are negation P and negation Q, because through the negative negation of this expression is also from the second point of DNF. Now third point is the De Morgan law is also applied in between here. What is the De Morgan law? Negation P or Q or negation of P and Q, okay, or negation P, this expression. Negation P and negation Q and negation P or negation Q. Now if and only it means next condition is that is an equivalent to next condition. Negation P and negation Q and P and Q or P or Q and negation P or negation Q. Now we are getting the, now we are applying the De Morgan's concept. Now the final concept is negation P and the negation Q and P and Q are P and, so this expression can also be written as this type of P and the negation P are Q and the negation P, okay, or P and the negation Q or Q and the negation Q. Okay, this is the final concept of now entire this proposition is the one of the from the defined negation of P or Q is an equivalent to P and Q. Okay, that's enough. Now this is the important concept here. Okay, at the same time, these expressions is also practiced from the short answer questions end of the topic is here. Now the answer is also compared to end of this unit. Q and P are of negation P. Okay, that's enough. See this in the CEO question. Next one, applying the disjunctive normal form of P and Q are R and P to R. This is the short answer here. Okay, first of all, you have to take in this one. Okay, solution is also here. Now this expression is also right here, and at the same time it is an equivalent to P and Q are R, and now P to R. How to write the P to R? Negation P or capital R. Second part is also can also be plus this one. At the same time, this expression distributive condition is also applied. P or R and Q or R and negation P or capital R. This expression is also in the same manner here. There is no change. But this expression can also be written as P or R and Q or R by the distributive condition. That's enough. So this is also very important short answers. Okay, that's enough. Next one, conjunctive normal form. Now, disjunctive normal form means elementary product is there. Now, conjunctive normal form means elementary sum. There is no change. Okay. A statement formula that is an equivalent to the given formula and consisting of a conjunction. Product of conjunction means that is the product of the part here of elementary sum is called. Okay, in conjunction formula product technology. So that is the elementary sum is called a conjunction normal form of the given formula. Now, following the definition here, we have to observe this one. In the statement is a tautology. If every elementary sum of its conjunctive normal form a topology. Very important concept is there. Conjunctive normal form, we have to consider the tautological expression. Finally, we are getting the result is tautological values. That is the tautology. Now it form a conjunctive normal form is dash intent. In Japanese, tautology or contradiction or contingency, whatever it is here. Okay, that is the answer is tautology. Conjunctive normal form a tautology or tautological expressions are here. Okay. Now, one of the statement is here. We are taking the A be the one of the statement of the variable. Okay, that is the proposition of the part. We know that now we have to express the conjunctive normal form. through the elementary sum. Sum means that is the expression of what is the negation of the part. Conjective చెప్పేటప్పుడు మనం రివర్స్ లో తీసుకోవాలంటే ఇక్కడ ఎలిమెంటరీ సమ్ అనేది ప్రతి చేస్తుంది ఆర్ నెగేషన్ అప్లై చేస్తుంది. Now you are considered the variable is capital A, that is the statement. Now that is identically true means A or negation A is identically true. Here just to have to the above expression is there. Conjective normal form part is A and negation A. Okay, that's enough. There is no doubt. Now here conjective normal form, that is the above part is A and the negation A is a disjunctive part. Here A or negation A is identically true. So this is the concept of conjective normal form. It is defined from elementary sum. Now it is from a tautology. That's enough. Now hence it is any elementary product A or negation A appears is a factor. Then now that is the reverse of the part from disjunctive normal form. Disjunctive normal form దాని కాంట్రోవర్సీలో చెప్పినట్లయితే ఈ కంజక్టివ్ నార్మల్ ఫామ్ అనేటువంటి ఫామ్ అవడం జరుగుతుంది. ఓకే, నెక్స్ట్ that is the identically true. Suppose statement is this is sir, there are so many searching, so many asking the so many types of this part conjective normal form. Now define conjective normal form and disjunctive normal form and explain briefly. So that is the concept here. Okay, elementary sum obtained the statement formula at least two factors. One of the negation is of the other. Same manner, there is no change. But here conjunction explained. Now in the part of symbol is if the negation is or negation. Okay, so your negation is identically true. That is also one of the wait. That is also one of the multiple choice question or fill in the blanks, whatever it is. Now according to this one, at the same time for elementary sum of conjective normal form a tautology. No, that is the final expression here. Now this is the elementary sum of this part. Next one. Now see this example, conjective natural. Okay, the conjective natural form is not unique. You have to observe this one. Is it unique? How to explain? Conjective normal form is not unique because now here the observer given this example is there. Obtain a conjective normal form P and of P implies Q, P and of P implies Q. Just a minute. Please stay on the line. Okay, now thank you. Just you have to give this example. What is this? Obtain a conjective normal form is P and P conditional Q. P and P conditional Q. Now this is also short answer or fill in the blanks is there. What is the conjective normal form? C and P is P and of P implies Q here. Okay, P and P implies Q means P implies Q. P conditional Q. How to write this one? Negation of P or Q. That's ends the matter. Okay. Simply P and P implies Q means P and is same. Now, what about the expression of P to Q? Okay. P to Q means negation of P or negate. Just we have to apply this one. That implication represented as negation of P or. Okay. Q is the same. Now, P and of negation P or Q, that is the conjective normal form from, that is the definition of the part is P and of P implies Q. That's enough. Okay. In the same manner, this is also there. Obtain the conjective normal form of the statement formula. Negation of P or Q if and only for P and Q. That's enough. Negation of P or Q is an equivalent to P and Q. First of all, we have to write this one first row. Negation of P or Q is also here and implies. Okay, this expression can also be written as this type of implies. Already expression is also mentioned in the above example is there. Now, this representation by is an equivalence expression can also be written as conditional of P and Q, and so this is capital A. That is conditional of capital A and A2 negation A. Okay, that's enough. Now P and Q conditional negation P or Q. Now this is the expression. Just you have to observe this one. P is an equivalent to Q means P to Q and Q to R. Sir, how to express the R? Okay, there are two variables here. There are two statements. There are two propositions. Now, how to express the equivalent part? This is the biconditional part. This is the equivalent part. Okay, this is the biconditional. This is the equivalent part. Now, P if and only if Q means P to Q. P biconditional Q expressed as the P conditional Q and the Q conditional R. According to the third proposition is also there because we have to is an equal from the for equivalence relation. Now, at the same time, here P or Q or P and Q, have to observe this one. Negation of P or Q means that is P or Q or P and Q and symbols automatically have to change. This is the disjunction, this is the conjunction, and the negation of this distribution. Okay, according to this, P, Q, and P, Q, P again is there. Now, in between these propositions, we have to express the disjunction and P or Q and negation P or negation Q or negation P. This is the relation of this one. Now we have to apply the negation of this part. That is the second condition of CLF. And negation P or negation Q or negation Q. Okay, this is the final expression which is defined from the above consideration. Okay, this is the conjective normal form. Now, in the same manner, last example is also here. Obtain the conjective normal form of the formula. Okay, these expressions only depend on during the final examinations. There is no doubt. Outside of the consideration is not considered here. Especially now, you have to practice from the according to the conditions, and automatically you must achieve for final result is there. Now, obtain the conjective normal form of the formula. That is negation P implies R and Q biconditional of P. That's enough. This is the biconditional part. Now, both equal and both sides arrow expression is called equivalence part. Now, that is negation P to R. So, suppose negation P to R and Q biconditional of P. That is the taken. Okay, enter this expression, consider the negation of the part. That is the second condition from CLF. Now, negation, you have to, this part is A, this part is B. What is the A and B? Okay, A and B means negation of A or negation of A and expression is there. Negation of A means this is, and Q to P and P are Q. This is the Q, if and only if P can also be written as this type of expression is there. Okay, now negation of negation is P. Okay, at the same time, R, capital R, and negation of Q or P and the negation P or Q from this expression. Now, final result is P or R and negation Q or P and negation P or Q. Okay, this is the result for negation P, conditional R, and Q by conditional of P. Okay, that's enough. Just this is the read and write. That is the concept of PMS. Okay, now what is the principal normal forms? What is the principal normal forms? Now, principal normal forms, just you have to observe this concept. Very important concept is there. Now, this is the last part of this unit. Now, P and Q be two statement variables here. Let P and Q be two statement variables. Let us construct all possible formulas which consist of conjunction of P or its negation and conjunction of Q or its negation. Okay. Now you have to observe this sentence is there. Now there are two statement variables here. Now construct of all possible formulas which consist of conjunction of P or its negation and conjunction of Q. Okay. Now that is the formation of taking the language for the given expression here or its negation. None of the formula should contain both a variable and its negation. Okay. Furthermore, any formula which is obtained by commuting the formula in the conjunction is not included in the list, because if a formula will be equivalent to one included in the list, for example, is there. Okay. Now, what are the example of principal normal forms? P and Q. Suppose we have taken P and Q, or Q and P is included but not both. Okay. This example is there. Okay. This formula P and Q or Q and P, it is included but not both. That is the separation of the part, either this one or this one, but both are not included. Okay. Now that is the principal normal form. Now, according to this introduction, what is the definition of this one? What is the Boolean conjunctions? Boolean conjunctions means suppose P and Q, so that is called a minimum terms. Definition of minimum terms means any two variables are taken. Two variables means that is the form expression is 2 square. Such formula given by, now we are getting the 4 expressions. One expression is P and Q. Second expression is P and negation Q. Third expression is negation is also applied in between the two statements for the connectivity. Okay, through the connectivity. Now P and Q, and at the same time P and negation Q. And the third one is negation P and Q. Fourth one is both are negation P and negation Q. Now these formulas are called minimum terms. This type of formula is called. Okay, how to explain the minimum terms or Boolean conjunction. Now this is the expression for conjunction. So this is the one of the connectivity. Through the connectivity, including the Boolean expression is there. There are two variables are here. That is P and Q are the variables. Now the final expression is 2 square. That is P and Q, P and negation Q, negation P and Q, and the negation P and negation Q. Now these 4 values are from the relation, from the concept is 2 square. Okay, that's enough. Now this is called minimum terms or Boolean conjunctions. That's enough. Now how to construct the truth table? Define Boolean conjunction or minimum terms. Okay, sometimes that is also called. Sometimes that is also called Boolean conjunction or minimum terms. If any one is given, the final exam is there. Okay. Now there is no confusion. Please understand. Keep in your mind. Now that is P and Q be 2 statements here. Okay. Now this is P and Q. This is P and negation Q. This is negation P and Q. Final expression is negation P and negation Q. These 4 expressions from the 2 propositions. Now, in final concept is now what are the how to take the values? This pair is 4 truth values are there. Now that is true, 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 false, false, true, false, false. Okay. Now in between conjunction is both are true is true. At least one is false. For those expressions, we are getting the result is false. Both are false. We are getting the result is false. That's enough. And at the same time, according to the Q, we have to just consider this type of column. Now nearby Q, just you have to write the column is negation Q. There is simply there is no confusion there. Now according to the P and the negation Q, we express the conjunction concept. Suppose this is false. Negation, this Q of the negation is false. True and false in between the conjunction is false. True and true, because negation Q value is true. So true and true is also true. False and false is also false. False and true is also false. That's it. Okay, that is easily understand. Now you have to write the another two is also in the same manner. there is no confusion. Okay, that's enough. Now, clearly, no two minimum terms are equivalent. Okay, ఏ రెండు మినిమం టర్మ్స్ తీసుకున్నప్పటికీ కూడా ఈక్వివలెంట్ గా ఉండదు. సపోజ్ ఈ రెండు తీసుకుని ఈక్వల్ గా ఉన్నాయా? ఉన్నాయా? లేదు కదా. కాబట్టి మినిమం టర్మ్స్ ఆర్ ఏ రెండు కూడా నో టూ మినిమం టర్మ్స్ ఆర్ ఈక్వివలెంట్. ఏ రెండు మినిమం టర్మ్స్ తీసుకున్నప్పటికీ కూడా ఈక్వివలెంట్ గా లేవు అని చెప్పచ్చు. ఈచ్ మినిమం టర్మ్ హ్యాస్ ట్రూత్ వాల్యూ. ప్రతి మినిమం టర్మ్ కూడా ఖచ్చితంగా ఏం కలుగుతుంది? ట్రూ వాల్యూ కలిగి ఉన్నట్లయితే ఫర్ ఎగ్జాక్ట్లీ one combination of the truth values of the variables p and q. చూసారా? ఈ ఎక్స్ప్రెషన్ లో ఒకటే ట్రూ వాల్యూ వచ్చింది. Now you have to observe this expression is also only one true value is there. This expression is also only one true value is there. That is the minimum terms concept. Okay, thank you. Next one, suppose three variables are taken. Three variables, according to three variables, how many minimum terms? That is the 8 minimum terms. Okay, two variables means 4 minimum terms. Okay. Now, how to take the 8 minimum terms? PQR with respect to the conjunction. Suppose both are P and Q both are negation in between the conjunction concept. Suppose negation P and Q and R, only P is the negation, other P is the same. Now, in between the conjunction P and the negation Q and the negation R. Okay. Now, P and the negation Q and R, these are all combinatorial values from the three variables. So easily to understand here. Okay, there is no doubt. Simple concept is there. Okay, P and the negation Q and R, negation P and the Q and the negation R. Now just you have to write this capital R, not C. Okay, P and the Q and the negation R, negation P and the negation Q and the all are negations in between the conjunction. Okay, that's enough. Now, in generally, if there are n variables, it is possible that we can form 2 power n minimum terms. Okay, that's enough. So, from the above discussion, it is clearly that the truth table of any statement formula containing the given variables is not. It is possible that an equivalent formula are containing the disjunction of minimum terms can be constructed. Now, three variables are taken and how to construct the truth table. See this one. Okay. Now, this is the observation. What is the canonical form? Okay. Easily. Now, through the three variables, how to construct the truth table. Okay, same in the same manner. Okay, already you have to practice in the previous classes. There is no doubt. Okay, now you have to observe this one. An equivalent formula consisting of distinction of minimum terms only is known as principal disjunctive normal terms. Principal disjunctive normal form. Okay, such a normal form is also called the sum of product canonical form. Disjunctive concept చెప్పేటప్పుడు product చెప్పాలి. Conjective చెప్పేటప్పుడు sum చెప్పాలి. So this expression is also called principal disjunctive normal form through the minimum terms. Through the minimum terms of the disjunctive normal form is called principal disjunctive normal form. Now, in sometimes that is also called sum of products canonical form. Okay, both are same. Principal disjunctive normal form or sum of products canonical form. Okay, that's it. Now, the truth table is also given. P2Q, PRQ, negation of P and Q. These three expressions must be involving for the given table here. Okay, just you have to clear observation here. Okay, PQ, P implies Q, PRQ, negation of P and Q. Okay, there are three considerations here. Now, easily to have to understand. There is no doubt. Already you have to establish some other expressions in the previous sessions. Okay, P implies Q, both are true is true. In implication, first one is true and second one is false. Is also the result is false. Remaining, the first one is false, second one is true. That is also true. Both are false is also true. So that is the P implication true. PRQ is also the same manner. So now according to the P and the Q, you have to establish the P and the Q. Suppose P is the negation of the value. False and true is also false. False and false. Okay. So this value is false. Negation is false. False is also false. Next one. True and true is also true. So just you have to, correction is here. Just you have clear observation here. So here is negation of P and Q or negation P and Q. Yes, P and P are Q, the same as this one. Negation P and negation Q means this is okay. So negation means F and T. F and T means F. Okay. Now here just you have to observe this one. This is also F because negation of P. F and F. Also F and F is also F, not true. This is the correction. Next one, true and true. That is also true. Okay, maximum terms also true here. Okay. Next, both are, this is true and false. True and false is also here. This is true and false. Negation of P and Q means P and Q is also, you have to first of all you have to find out the P and Q. Finally, we are getting the result is negation. Negative values are maximum terms are true here. Okay. So this is the concept. Now P plus Q can also be written in the disjunctive normal form this type. What is the P conditional Q in the disjunctive normal form? P and Q are negation P and Q. Okay, this one. P is connected. P is connected. This one. P to Q means P and Q are negation P and Q. This is or negation P and negation Q. These three connectivities included with respect to the disjunction, that is called P conditional Q. And at the same time, P or Q means P and Q, P and negation Q, negation P and Q in between the disjunction of this part. Okay, how to write the disjunctive normal form P or Q? That is an equivalent to this expression. At the same time, negation of P and Q means that is an equivalent to P and negation Q or negation P and Q or negation P and negation Q. So one is negation. Here, first one is negation. Now, both are negation with respect to the conjunction concept in between disjunction. That is called negation of P and Q. That's enough. Now, these are all construction tables easily to practice. Now, how to construct the P2, P and Q conditional P. So that is the main expression here. Just please stay on the line. Thank you. Now everybody understand here. Any doubts? Please respond. Please raise your hands. No. Andru follow uttara. Okay, thank you. Remaining 2%, please cooperate. Okay. There is no response. Thank you. So, next one. Obtain the principal disjunctive normal form. Obtain the principal disjunctive normal form of the formula. P conditional of P and Q to P. P and of P conditional of, this is the bracket here, P and of Q to P. This is the entire part is Kepler. How to write the P to R? Negation of first statement, first proposition R. Okay, this concept is capital B. This is A. Now, how to A conditional B? According to this one. Okay. Now, P and Q. Now, that is the construction table is P and Q. There are two propositions and write the Q to P. That is the reverse part. P and of Q to P. Because in the right hand side is this is. Now, according to the expression, we are taking the values. You are taking the expression in the truth table. Now, P and Q. You have to observe the how many variables here, how many propositions here. There are two variables, two propositions, P and Q. Now, unknown part is Q to P. That is the one of the column. Now, second part is also taken in this one. Now this is P is the capital A, this is the capital B. Now A to B expression right here. All values are true. That is the concept of disjunctive normal form. Now the final expression is for all the values are true. That is called, what is the principal expression? Disjunctive normal form. According to the disjunctive normal form, for the minimum terms, that is called the principal disjunctive normal form expression. We are getting the result is all values are true. Now that is called tautology. That's enough. Okay. Next one. This is the tabular method. This is the non-tabular part. Non-tabular part completely depends upon the equivalence expressions. Okay, that's it. Equivalence expressions. This is already I have to practice here. Next, some observations for the PDNF. Now, already I have to explain the discussion is there. Problem is considered. Now, this discussion, the made above and the problem is also considered, and observe the following conditions here. Okay, every formula which is not a contradiction has an equivalent PDNF, which is unique. Now, already in the previous session is there. Now, conjunctive normal form is not unique, but here the PDNF which is unique means now every formula which is not a contradiction. Not a contradiction means that must be an equivalent to PDNF which is unique. That's it. Second condition is equivalent state formula, statement of the formula, identical principal disjunctive normal forms. Okay, statement formula, equivalent statement formula, that must be it have identical PDNF. PDNF means principal disjunctive normal form. Now, PDNF contains, what is the PDNF contains? All minimum terms, then it is a tautology. According to these three conditions, we have to construct the above construction table, and according to the equivalence forms and their expressions of DNF. Now, indirect method. This is the direct method means truth table. According to the truth table, and indirect concept is it is completely depends upon the expressions. Okay, that's enough. Thank you. Next one. Okay. Now, some other examples are also here. Okay. Now, these examples completely depends upon the above points. Okay. First of all, first replace conditions. Now, we discuss under the method to find principal disjunctive normal form without constructing a truth table. Now, to construct the in examination is given without construction table to find the principal disjunctive normal form. Now, to observe these 6 points, already we have explained here. Now, these points depends upon to solve the problem, to solve the given the consideration, to solve the solution given this expression of PDNF. Okay, thank you. This type of expression. Okay. Now, first of all, we must know these 6 examples. Now, the final condition is also we have to observe this one. Identical minimum terms appearing in the disjunctive or deleted. Now, these 6 conditions must applicable for this consideration. Okay, that's enough. Now, this is also here. Applying the principal disjunctive normal form of the formula P biconditional to P biconditional Q. Sometimes can also replace this type of P biconditional Q equal only to P to Q and Q to P. This the relation. What is the principal disjunctive normal form? P biconditional Q means P to Q and Q to P. P to Q consideration, this type of consideration. P to Q expression is negation P or Q. And Q to P consideration is negation Q or P. This is the second part. Okay. Now, these you have to observe these 2 are okay. Negation P or Q and negation Q. You have to take this one, this part. Or negation P or Q again and of R. That is and P. Negation P or Q and P. Okay. Now, finally, we are getting the result is negation P or negation Q or P and Q. Now, all the results you have to observe for the 2 variables. Now, we are getting the 4 expressions. Now, with respect to the four expressions P and Q or P or Q, okay. Now, P negation P or Q, negation P or negation Q, negation P or negation Q. Now, that is the conjunction, is the conjunction of distinction of this one. Okay, that's enough. Now, this is the simple solution. This type of. Now, this expression can also be written as this is. Now, entire this part is not unique. Okay, this part consideration P if and only if Q means P biconditional Q. Now, P biconditional Q can also be written as this type of this part. Now, this part is also consideration. This is negation PR. That's it. Now you have to practice the so many concepts are there. Now check your progress and also practice. Hello. Hello. Any doubt? Hello. Any doubt is there? Next one. Okay, principal in the same manner, principal conjective normal form is also same. Conjective means you are taking the disjunction part. Okay, disjunctive or principal, the disjunctive normal form you are taking the conjunction part. Okay, that is the variation is there. Disjunction you have to take the conjunction connectivity, and the conjunction normal form you have to express the disjunction connectivity. Now that is the variation is there. Just now he explained the this is the definition of product of sum. Okay, principal conjective normal form means that is the maximum normal form is also called. For a given statement formula, an equivalent formula consisting of the conjunction of maximum terms. Minimum terms means principal disjunctive, maximum terms of conjective normal form is principal conjective normal form. Sometimes that is also called product of sums okay, product of sum canonical form. Product of some canonical form that is also said to be a principal conjective normal form. It is completely depends upon the maximum terms of the CNF. Okay. Now these are all looking at observations here. These four observations according to the for the given part for the given problem is there. Without a truth table, without construction of a truth table, how to construct, how to write the expressions. First of all, we must know these four observations are here in the above same manner principal PDNF. Now automatically then we have to find the PCNF is also there. What is the PCNF? Principal conjective normal form. Okay, thank you. Next one. Okay. Now time is also completed here. This is the second part. The second unit is also completed. Now in the same manner, third part is also there. Now you have to express the one of the important role is there. What is the theory of inference for statement calculus? Okay, theory of the inference for statement calculus. Okay, just to have final conclusion, the previous last two units. That is, from the 2 units, you have to observe the already one essay is given. Okay, there is the matter. There is no doubt. One essay is also completed there. Next one, there are 2 short answers. Now, from these 2 units, we are getting the yearly, okay, 28 to 32 marks are there from the 2 units. This is the first block. Okay. Now remaining marks is also depends upon the second block. Okay. Now this is simple variation. Just you have to mark the important concept give the consideration. What is the validity using truth tables? Okay. Now theory of inference for statement calculus. Calculus means okay, that is the calculating part. Means what is how to calculate the statements of the theory of inference. Okay. Now it must be, now we have to observe this one. Every value is true here. The word inference will be used to designate a set of premises accompanied by a suggested conclusion regardless of whether or not the conclusion is a logical consequence of the premises. Now there are faulty inferences of and valid inference. Each inference can be written as an implication. There are one of the important point is there. Just you have to observe this one. Okay. Please stay on the line and take the attendance now because the time is already completed. But I must explain that there is no doubt. Okay. Now, class అయిపోయినప్పటికీ ఎక్స్టెన్షన్ యొక్క పార్ట్లో నేను కంటిన్యూ చేస్తాను విత్ యువర్ కోఆపరేషన్. If it is not necessary, please explain there. Okay. Thank you. Okay. So all are okay. Please cooperate with me and to express your views and share with me. There is no doubt. If you have any doubt, you must contact with my number because some doubts are arise through the online. Now, if you have any doubt, I have to rectify through the WhatsApp or personal calls. There is no doubt. There is no confusion here. Please cooperate. Okay, thank you. Okay. This is one of the important source to online concept, online coaching. Now, online classes is also well established from the university program. Okay. Now here, what is the conjunction of premises? Okay. Somebody is also. Okay. Conjunction of premises implies conclusion. Conjunction of premises implies conclusion. Now, that is the completely in mathematics. A theorem is proved by constructing a proof with a sequence of statements. What is the importance of this one? Conjunction of premises goes to conclusion is there. Okay. Now the conclusion is also there. Suppose in first part is called initial part and the final part is called terminal part. Now there are so many theorems you have to observe in the mathematical concept is there in the first year or second year or final year. There are so many theorems you have to prove. Now, in this manner, a sequence of statements that form an argument. A sequence of statements that form an argument. That statements used in the proof include some axioms and a few theorems. A statement that proof includes some axioms and a few theorems. Results proved earlier. Results proved earlier. But inference a logical process of making conclusions from a set of given premises, the laws and the rules of reference, which are the means used to draw the conclusions from other assertions tied together the steps of proof. So, mathematics lo మనం number of proofs చూసామండి. ఈ proofs అన్ని కూడా మనం ప్రూవ్ చేయాలి అంటే లాజిక్ ని బేస్ చేసుకుని మనం చెప్తూ ఉంటాము. అలాగే ఈ లాజిక్స్ చెప్పేటప్పుడు ఈ కనెక్టివిటీస్ ఆధారంగా కూడా ఏమండి మనం there are so many theorems are derived here. Okay. Now that is either computer programming correct చేయాలన్నా దీన్ని కంప్యూటర్ సైన్స్ అప్లికేషన్స్ ఎక్కువగా యూజ్ చేస్తూ ఉంటాము. ఈ చేసేటప్పుడు కంప్యూటర్ ప్రోగ్రామింగ్ మనం కరెక్ట్ చేయడానికి కూడా అలాగే ఎస్టాబ్లిషింగ్ ద ఆపరేటింగ్ సిస్టమ్ అంటే వాట్ ఈస్ అన్ ఇంపార్టెంట్ ఆఫ్ దిస్ వన్ మీన్స్ కంప్యూటర్ ప్రోగ్రామింగ్ ఆర్ కరెక్ట్నెస్ అండ్ ఆపరేటింగ్ సిస్టమ్స్ ఆర్ సెక్యూరబుల్. ఓకే, దట్స్ ఇట్. నెక్స్ట్ వన్, validity using the truth tables. What is the validity? It's very simple concept is there. Okay, you have to observe clear. A and B are two statement formulas. A and B are two statement formulas. We say that B logically follows from A. Okay, there are two statements you have taken. What is the A to B? A to B is the tautology. Now we read as that is the conclusion of the premise. Yeah, that is B logically follows from A. Whereas B is valid conclusion from the premise A. That is that can also be written as this is A goes to B is a tautology. So that is the meaning of A implication B. Okay, in the validity using truth table means this is the concept. However, distinction between an implication, this is the implication of the part, it is implication of the part. Now, in this inference, A implies B does not guarantee the truth table either A or B. But the truth of the inference P and P to Q, P and of P to Q does guarantee the truth of Q. There are some of the premises is there. A conclusion capital C is there. H1, H2, we are taking some premises H1, H2, so on, HM. There are first house, second house, and so on. M the type of house is there. In between, we have to express the conjunction is there. H1, it read as H1 and H2 and H3, so on, and HM. That is an implicated as capital C. C is the conclusion. C means conclusion. This is the logically means C conclusion logically means if and only if that is the concept. H1 meets H2 meets so on HM and implies capital C. That's it. Now this one truth table technique is this explain the following steps. What is the techniques of explain the truth table techniques? Okay. Now from the these three conditions. First condition is identify all the atomic variables P, Q, or S appearing the premises is H1, H2, so on HM. Okay, and the premises based on atomic variables P, Q, R, S and also the conclusion is we are getting the result is capital C. So sometimes is given this type of notation as there. We are taking the replacing of H1 by P, H2 by Q, and so on H3 by capital R. In the same manner, other consideration also there. Now assign all possible combinations of truth values to P, Q, R, S and evaluate the truth values of the given premises H1, H2, so on HM as well as capital C means conclusion for all considered combinations. Identify the rows in the table in which all the premises of the truth table is capital T. Okay. Now these three conditions are truth table technique. Okay. Now one of the example is there. What is the example? Show that a conclusion capital C follow from the given premises H1, H2 is there. What is the H1? Okay, P is the atomic variable. That atomic variable is connecting with one of the connector is negation P. That negation P is considered H1. And what is the H2? P or Q. There are two premises. What is the conclusion? Negation P is suppose P is true, negation P is false. P or Q. Okay, so this is negation P, and this is this type of how to write the solution. Conclusion of premises means now H1 and H2 is given. What is that? Conclusion of premises goes to conclusion. What is the truth table? Negation P or H1 between H1 and H2 can also be written as negation P or P, negation P and P or Q. That is the conclusion of premises. And goes to conclusion is C. C result is we are getting the result is Q. Suppose negation P or P means negation P or Q. Negation P and or P or Q. That result is Q is there. Okay. Now according to the truth table, we have to observe this one. PQ. Now according to the P, according to the propagation of P, write the negation P. And that expression H1 and H2 expression is P or Q is there. Now write the in between from the P and Q proposition, you write as P or Q. And again, this is A, this is B. This is A, this is B. Okay. Now according to this one, you have to construct the conjunction concept. Okay. What about the final result? Capital X is there. Suppose we are taking these values are here. Okay. What about the capital X? Implication. Okay. This is the implication part. Now this result goes to capital Q. Okay. F and true is true. F implies F is true. True and true is true. False and false is true. That is the conditional part is capital X. Okay. ఇక్కడ ఇచ్చినటువంటి రిలేషన్స్ చూడండి H1 H2 అనేటువంటి ఇచ్చాడు. ఈ రెండు ప్రిన్సెస్ ని బేస్ చేసుకుని మనం ఏంటంటే ఇక్కడ మెయిన్ కాన్సెప్ట్ కంక్లూజన్ ఆఫ్ ప్రిన్సెస్. ఏ ప్రిన్సెస్ అయితే మనకి ఇచ్చాడో దాని యొక్క కంజక్షన్ ఆఫ్ ప్రిన్సెస్ అన్నారు. కంజక్షన్ అనగానే దేంతో చెప్పాలంటే అండ్ తో చెప్పాలి. ఈ రెండిట్ల మధ్యలో ఉన్నటువంటి కంజక్షన్ ఈ విధంగా రాశాను. కంజక్షన్ ఆఫ్ H1 అండ్ H2 అది ఎక్కడికి పోతుందండి? నౌ దట్ ఈస్ ద కండిషనల్ ఆఫ్ Q. కండిషనల్ మీన్స్ ఇంప్లికేషన్ ఆఫ్ Q. ఈ వచ్చినటువంటి రిజల్ట్ ని Q మీదకి ఇంప్లికేషన్ చెప్పాలి. చెప్తే వచ్చే రిజల్ట్ ఏమవుతుందంటే X అవుతుంది అని చెప్పి మనం చెప్పచ్చు. సో దట్ ఈస్ last you have to observe the last column. All the values are tautology. All the values are two values. Now we are getting the result is tautology there. Okay, that's it. Now there are three houses is given. Two houses is given. First premises is P2. P implies of Q implies R. Second premises is P and Q. Now we have to express the in between H1 and H2 is the conjunction part is there. Now already expression is here. Conjunction of premises goes to conclusion. Okay, ఈ రెండిటి యొక్క కంక్లూజన్ థర్డ్ వేరియబుల్ ఏమవుతుందంటే మనకి ఇక్కడ క్యాపిటల్ R అవుతుంది అని చెప్పి చెప్తున్నాం మనం. అంటే క్యాపిటల్ R అని చెప్పి చెప్తున్నాం. సో లాస్ట్ వేరియబుల్ ఇక్కడ లాస్ట్ ప్రపోజిషన్ R కాబట్టి దాన్ని బేస్ చేసుకుని ఈ మొత్తం ప్రపోజిషన్ R మీద చెప్పినట్లయితే కండిషనల్ పార్ట్ చెప్పినట్లయితే లాస్ట్ హౌస్ కూడా ఏమవుతుంది? H1 and H2 goes to capital R. All values are true. Now that is called tautology. Okay, three values ఇచ్చినప్పుడు three variables ఇచ్చినప్పుడు ఎలా తీసుకోవాలి? ఇది H1 పార్ట్ అండి, ఇది H2 పార్ట్. ఈ రెండిట్లోనూ కూడా ఈ ప్రిన్సిపల్స్ లో ఎన్ని వేరియబుల్స్ ఉన్నాయంటే మనకి 3 వేరియబుల్స్ ఉన్నాయి. 2 cube 8 considerations వస్తాయి. Already yesterday I told first 4 values are true and the remaining 4 values are false. Next second remaining 2 columns are there. Both are true, true false, false true, false false. Okay, in the same manner represented as remaining 4 rows. Okay, true true, true false, false true, false false. Now today we have this here to announce the 3 variables. Now we have to express the 3 variables here. Now this is the P and the Q. Unknown factor is here, P and the Q, and second one is Q2R. That is another column. Now to express the P2 of Q2R, this is another column. Now this part is P, this part is H1, and this part is H2. To express the H1 and the H2 right here. Okay, this column. And at the same time, H1 and H2 implies with capital R. H1 and H2 implies with capital R. Okay, that is called final part is there. So this is the expression of H1 and H2 goes to capital R. All values are true in the last column is there. Okay, the two premises kuda capital R and the third variable in the preposition. If all the values are true, that is called all the values are true means that is called tautology. Okay.
Hello sir.
Hello sir. Hello. 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 Thank you. Thank you. Okay na?
Sir, next class ఉంది sir. Sir.
Sir, sorry sir. Thank you. Thank you. Okay sir. Wish you good luck each and everyone. Now from these 3 units, very important concepts. How to follow the third unit is also there. Thank you very much. And tomorrow